Hey everyone, and welcome back to the shop. Today I had a job come in and I thought it would be a good opportunity to make a unique video that has a little bit of aluminum welding as well as some machine work. So I need to fix a cylinder head on a Harley Davidson. I usually don't do a lot of work on motorcycles, but this is for someone else I know, and they thought my expertise would be right for this project. So this is a 1200 cylinder head, I believe. I'm not exactly sure what year it came off of. I don't know a lot about Harleys, but someone else has already tried to fix the cylinder head and it made the situation much more complicated than it needed to be. So basically we have the exhaust flange. One of the holes had the threads completely pulled out of it. At some point someone tried to retap it and then drill it and drilled it crooked. And then they tried to weld it up with a MIG welder with steel wire. And if you don't know, this is an aluminum head. So they filled the hole with steel. I'm not even sure how they pulled that off, but they did. And then they tried to drill that. And obviously the drill bit wanted to go into the soft aluminum, not into the steel. So there's another second hole drilled crooked in the opposite direction. All of this was apparently done while the cylinder head was still on the bike, and from what I understand, the frame is a little bit in the way to even get access to drill a hole straight to begin with. So they brought it to me, they sent me a couple pictures, I saw the situation, and basically I said, all right, I think I can fix it, bring it down, let me see what you got, and make sure you bring the flange from the exhaust that's supposed to get bolted there so I can figure out where the hole is supposed to be when we go to make the new hole. So we're going to get this thing fixed up. I have a game plan, so I hope you enjoy watching. If you like it, make sure you give this video the thumbs up, hit that bell for notifications, and please subscribe. So here's the head. I already did a little bit of work, and what I did was I took a sharp punch and a hammer and I got underneath that bit of steel, and I was able to knock that steel out of the hole and expose exactly what's going on. So there's the piece of MIG weld that we knocked out of the hole. It's even got a piece of wire that was down in there. It was half drilled through. I'm gonna get some light on here, but there's a hole drilled at one angle, and there's a dirty hole drilled at a completely different angle on this exhaust port. And this whole corner is severely damaged. When we put the flange on here and put a bolt in that hole, we find that the location of the hole needs to be right in the center between these two holes. I'm going to end up basically cutting this whole corner of the cylinder head off. That way I can get all the contamination out of the way, really clean it well, and then build this whole thing back up with weld, reshape the outside of the cylinder head, reshape this top surface, which really isn't critical because the exhaust actually goes in this bore and seats with a gasket on this ledge with this flange that presses it all together. This top shape just has to be flat and to the right dimension. This outside shape's not super important either. It's purely just cosmetic. What's most important at this is welded up solid with a lot of integrity. That way this hole can be put in the right location, drilled and tapped, so it can have a good strong thread to pull this flange tight. These holes are both so deep, you could really never get all the way down in the bottom there. So in all reality, might as well just cut it out, get the contaminations off the head, clean it well, weld it up, machine it, drill it, tap it, good to go. So that's what we're going to do. See the sparks flying? Because there's still steel in the bottom of this hole from it being attempted to be MIG welded. Big chunk of steel still in there. Let's see if we can chip it out. This whole middle piece here is weld, possibly some original bolt even, that's still in the original hole. I can see the edge trying to separate. We gotta try to get behind it. The only thing I want to be sure to preserve is this original bore. I don't want to have to remachine that. Quote I gave this customer was not including thinking I would have to mess with that bore, so I'm trying to avoid it. So right in the middle of this mess, deep down inside of that hole it's drilled that way, this hole it's drilled that way, I center punched a piece of steel that's still in the middle of those holes at a third angle. So you've got this entire corner cut away. You can see how deep those holes were drilled. There's still some hole left. They ran them way in there. I'm hoping that piece of steel that's left in the bottom of this hole is a piece of original stud or bolt. And I'm going to TIG weld on there and see if I can pull that out of there, as gnarly as it is. That way I won't have to keep grinding and making this even deeper and deeper. I'm going to try to pull that out of there. I imagine it can't have too many threads in there still. It can't go that deep. This hole there is not that deep, so it's probably close to the end. Let's see if I can get that out. Alright, so I built up a little weld off that piece of steel. We got a little stalactite there now. We can get a grab on and hopefully get this out of there. It's going to be tough to grab because it is so close in that corner. Let's see what happens. Something's turning. I don't know if the weld's trying to break or if I'm rotating the bolt. It is spinning on an eccentric, so I think I'm turning the bolt. And yep, we're even starting to see some threads come out. Let me grab a light. You can see those threads that are showing. They were spun against that back wall. But since I rotated it about 20 degrees, you can see the threads are coming out. I really wish people would just bring me their issues before they make them worse. I guarantee you I could have got that broken bolt out on the bike in about 20 minutes with my TIG welder. I don't care how tight this is in the bike. If you can see it, I can weld it. If I can weld it, I can get it out. And this thing's mangled, and I'm screwing that gnarly oval piece out of this hole. I could have fixed this a lot easier, but now the engine's apart, it's a mess. So hopefully videos like this just show people to just leave some things to the professionals, but let's get this fixed up. Now the problem is going to be, now that I can see the exact angle that that bolt used to go, this weld might actually be in my way. Now that I've got this thing spinning, I can probably knock that piece of weld off of there and then thread that out with a center punch. Let's see what happens here. I can't grab it very strong. The end of these needle nose. It's really about all I can even fit in here. Those don't even fit. I'm not about to grind down and modify a pair of pliers just for this one job. God, it turns so easy too. It's too close to the walls to weld a nut onto it. You'd never be able to get anything on it, anything behind it, spin it out. I could think about taking a long socket head bolt and trying to weld it on there and using a tool up here to spin it out. But I think I can get this out without going to those steps. Actually, you know what? I'm going to try welding the socket head bolt on there. I think I'll have enough leverage to use it to basically that back thread that was drilled on two sides is trying to cut into the good thread that's on the back side of this hole, and the thread's messed up, so I have to basically cut it in. And I can't get a good enough grip with the needle nose, so I think if I had a Allen head on there, I could just force it out. Alright, as I walked over to the hardware, I realized I'm too much of a cheapskate to waste a good Allen head. So I'm going to use a junk American bolt. It's long enough I can put a wrench on it. Try my best not to break my weld off. I can only weld one side of it. It's real tight right there. Funny thing is, I can actually screw it in tighter than it was and expose some threads on the other side. Just hits this one spot, just doesn't want to go any further. You can see the weld trying to twist. Tell you what, now that I have the back side exposed, we've got a whole 180-degree turn out of this thing now. I'm going to add some weld to the back side. Maybe it'll make this a little stronger and we can really force it. It feels like it's got some sort of pin lock, which can happen when a hole is drilled next to or halfway through an old bolt, and then you get a piece of weld in there and it creates a lock, like a keyway. It just won't go. There's no way. This thing's just too screwed up. So I'm thinking a little bit of the weld Might be just touching this wall as that turns down. It's really hard to see in there and tell, but it might be some of our bind, and it's just barely touching it. It's definitely the thread screwy, but I think that in combination with some of the weld touching the wall is making it so I can't force it by. I'm thinking if I grind a little bit of that weld off, I might be able to get it to force past and get it out without doing anything crazy. Ooh. That's progress. Gotta love it. It might be a little hard to tell, but that factory hole is really deep still, considering how deep we already are into the corner of the head. You can see the hole drilled to both sides, totally different angles compared to what it needed to be, totally wrong location. That thing's way down there. What we need to do is measure from the bottom of that hole to this top surface. Document that so we know when we put the new hole in how deep to go. Just trying to get this not so gnarly first. So we've got 3 different holes. We're almost to the bottom of these 2. The factory hole is significantly deeper still. I'm not super concerned about getting to the very bottom of the factory hole because we're just going to punch right back into it anyway. I grabbed 2 different carbide burrs. Neither of them are for aluminum. They're both tight cut pattern, I'd call them, for steel. But for the 30 seconds I need it for, I'm going to be lazy and not have to change it out. Type will work, they just clog up if you're really trying to cut a lot of aluminum. I'm just using this to really get into the bottom of these bores and clean out any contaminants. Make sure I've got nice, clean aluminum. Gotta be real careful because I'm not super familiar with the design of these heads. I know it's an air-cooled engine, so I'm not gonna like bust into a water jacket or anything, but I can see this exhaust port. I know where that head bolt goes through. Pretty confident there's nothing in here I can break into. Almost like a dentist drilling out a cavity and fill it up from the inside out. You don't want to have all these little different tubes and everything going all around. You'll never be able to get in and fill up and have a air pocket in it when you're done. But I think we're ready. So we notched the whole corner out and then we kind of dished it, bolted it out around all those, there you go, around all those wrong drilled holes. So we should be able to just fill it up like a bowl and build up the entire corner. I'm going to use some 40-43 rod. It's 3/32. I don't want to go too thick. I want to build this up slowly from the inside out. And I'm going to turn pulse off. With something this thick, pulse is just going to really make it take way too long to get hot. We're not trying to run dimes here. Alright, now I'm going to give my welder a break for a few minutes. The fan in that thing is screaming right now. But that 3/32 tungsten is doing a really good job of handling this amperage. It's not trying to burn back. The ceramic or lava cup, whatever you want to call it, is also holding that amperage really well. And my TIG welder is only a 200 amp machine. I'm running this thing 100% all out. We really got the bottom of that bore to wet in, get good penetration 100% all the way around. We've got it filled up pretty well and for the most part smoothed out. Now we just need to build up that actual corner of the head. A lot of contaminations and things have been, floating up to the surface of that aluminum weld. So I'm going to let that cool off for a few minutes, let the welder chill out for a little bit. And I'm going to take a sander and I'm actually going to grind the top of my brand new weld off. What that's going to do is all that contamination that has floated up out of the weld is basically solidified on the surface of that weld. And if I start welding again, it's just going to sit there and float around on the top of the new weld. The only way to get it out of the weld is to physically remove it. It's a good trick anytime you're welding dirty aluminum. All that black stuff that comes up to the top of the weld creates porosity. Just stop welding, grind the top of the weld that you just put on, remove the contamination off the panel, off the part, and start welding again. So basically now the cylinder head is on like a 45. It's all filled up all the way down the bottom, all the way around, and we have the whole thing on a little bit of a 45-degree angle. We'll get out any porosity and contaminants with the grinder. Then we'll finish building up this whole corner. We'll build it up a little proud so we can shape it. Now I gotta be real careful I don't melt back this edge of that bore. So I'm pretty confident I have enough weld build up, so I should be able to shape all three surfaces back to original shape, design, and flatness. Then we can get this in the mill and put that hole in the correct location. So it's about midnight right now, and this cylinder head is just way too hot to handle and work on at the moment. So I'm just going to let it cool off all night. Tomorrow morning we'll shape that weld to the correct design, get it nice and flat. We'll figure out how to get that hole in there and get this thing finished up. Well, I hope you like what you've seen so far, but make sure you click that link below for part 2 of this repair video. Next, we're going to figure out how to fixture this into a Bridgeport mill, get that hole machined out and threaded to finalize this repair. So click that link below, and please don't forget to hit that thumbs up and subscribe.